We are now trying to find a general factoring strategy. So, in other words, when I'm looking at a polynomial, how do I know what kind of a method I have to use when I want to factor the polynomial? The first thing that we are always going to do is we are going to always look for a common factor in all of my terms. So the GCF, that will always be number 1. Always do this first before you attempt any other methods. Now after that, I will just look at how many terms does my polynomial have. And there are really only 3 different cases. In case my polynomial has exactly 2 terms, then I have to try whether the difference of 2 squares or the sum or difference of 2 cubes. Now, if my polynomial has 3 terms, then it can be either 1 times x squared plus bx plus c, or if there is another number other than 1 in front of here, then I will have to use this factoring by grouping methods. Now, the last case, if there are exactly 4 terms in my polynomial, then I always have to try to factor by grouping. But never forget, GCF would come first in case there would be something. Let's do one of each real quick to remind us how to use all of these different strategies for our polynomials. So, I'm going to go really rather quickly, and I will factor all of these. I want to factor these polynomials here on the left side. Here's 1, there's another one, here's 1, here's 1, 1, and down here there will be another one. So, I look at this first one right here, 8x squared plus 4x. There are 2 terms, but there is also a GCF. The greatest common factor would be 4x between both terms. So I would pull out a 4x and I would be left with 2x plus 1. This one, there was a GCF. Now the next example, there are exactly 2 terms, and this is the difference of 2 squares. And we said the way that I am trying to factor this is by first rewriting it in this form, and then now all I have to do really is just to write it down. And the next one, we have again 2 terms. You notice there is no common factor between these 2 terms. And 8 is a perfect cube, x to the 3rd is a perfect cube, and 1 is also a perfect cube. So this is the sum of 2 cubes. Similar to the difference of 2 squares, I'm just going to rewrite it. 2x cubed plus 1 cubed. Now I see what is a and b, and I use my SOAP method, same, opposite, always positive, to write down my factored polynomial. Now, in my second factor, the first term was 2x squared, so 2x times 2x, that would be 4x squared. 2x times 1, opposite sign, plus the last one squared, 1 squared. All right, now this example down here, there are 3 terms. The leading coefficient is 1 in front of here, 1 times x squared. So I'm looking for 2 numbers whose product is negative 12, but whose sum is negative 4. And these 2 numbers are positive 2 and negative 6. Hold on, this doesn't look really very nice. Let me write this again. 2 numbers whose product is negative 12, but whose sum is negative 4. Negative 6 plus 2. Which factor comes first does not matter. I'm double checking. Negative 6 times 2 is negative 12. negative 6x plus 2x is negative 4x. All right, let's have a look at the next one. This was the slight little trickier one. In this case, the first thing that I had to do is I multiply the leading coefficient with the constant. 3 times 5, that is 15. So in other words, I'm going to set this up as the following. I write down 3x squared and positive 5, and in the middle, this middle term right here, the 8x, I had to split into two terms so that I then can use factoring by grouping. I'm looking at 15, and I notice that 3 times 5 is 15, and 3 plus 5, that is 8. That means 3 and 5 are going to be working. Plus 3x plus 5x. And now what I'm going to do, I use factoring by grouping. Here's one group, here's another group. And I see that in my first, there is a 3x that they have in common. I need to move this here a little bit on the side. That was just side work. So 3x factored out of 3x squared will just leave an x, and 3x factored out of 3x will just leave me a 1. In my second group, there is a common factor of positive 5, and it also leaves me with x plus 1, which is exactly what I wanted. That means x plus 1 comes out, and I have a second factor, 3x plus 5. 3x plus 5. All right. Now, the last example right here, this one has exactly 4 terms. So I use directly factoring by grouping, the trick that we have used already in the prior example. So I'm going to look at my first group, x cubed plus 2x squared. There is a factor of x squared that both terms have in common. Taking an x squared out of x cubed leaves me with 1x. Taking the x squared out of 2x squared leaves me with the 2. Now, the second group, negative x minus 2, it starts with the negative. That means I will factor out the negative 1. Oops, I messed that one up. This last example right here was supposed to say negative 2x. All right, so I factor out a negative 2, and I will be left with the x and plus... Oh, nope. This last example was right. That means I will just factor out a negative 1 down here. All right, let's have a look. So if I factor out a negative 1, then I will be left with x plus 2, right here out of these terms. I just factor out the negative. All right, that now leaves me with x plus 2 times x squared minus 1. Here there is a 1 standing in front of it that we do not need to write. All right, now this right here gives us the opportunity to look at something that we will always have to do. In this last example, I factored and I will get x plus 2 times x squared minus 1. When we are factoring, we are always factoring completely. That means if there is something else that I can still do, I will have to keep on factoring. Quick example for numbers. For instance, the number 20. If I want to factor the number 20, then I could say, all right, the number 20 is the same thing as 4 times 5. But I could also go one step deeper and say that 4, well, that is the same thing as 2 times 2. So 20 completely factored would be 2 times 2 times 5. And the same thing works here for the last example. You have probably seen it already. This second factor right here is the difference of 2 squares. So I would have to, the first factor cannot be broken down any further, but x squared minus 1 is the same thing as x plus 1 times x minus 1. And then I have completely factored.